Okay, let's get going. Good morning, everyone, and welcome to this, our fourth installment of the overall value proposition of distributed fiber optic sensing in the mining industry. Today's session focusing on tailings and high walls, as you know. My name is André Veldsman. I've been working as a sensing and sensor technology specialist for the past 15 years. Um, I head up Position XT. We are a strategic global partner to Hydro Research. Just some housekeeping before we begin. There will be a Q&A, a question and answer session at the end of the session. You can type your questions in the Q&A section below as they come up. Then without further ado, I'd like to pass the floor over to Dr. Johansson. He'll do a short introduction and then continue with the webinar. Thank you. Sam?
Thanks so much for the invitation for this meeting. I'm happy to present what we have done here in Sweden. And my background is a dam engineer. I've been working with hydropower dams and with tailings storage facility for about 40 years. And been working with developing new methods for investigation and monitoring of dams. I have also been a member in the ICOL committee on monitoring for about 20 years also. So I hope to give you a small presentation of what can be done with optical fibers in dams. And I will not go into detail about the monitoring. I will more focus on the application, how we are using this technology in dam monitoring and in TSF monitoring. So I will show some applications and the results from real case. Unfortunately, we are not allowed to present all results. You know this pretty well. I assume you have the same situation, but everything that I'm presenting here is so to say official, and I am allowed to use this. So let's dive into this. We started with using optical fibers in 1998, where we made the first installation. And you can see here on the screen that we have had a lot of installations here in the early 2000 here. And you can see that this is the hydropower dams and tailing dams in Sweden. And we are coming up to about almost 100 dams here in Sweden where we have fibers installed, and a lot of cable, 160 kilometers, and you can see that we are making a few installations each year here. Some of those we have permanent installation with monitoring, and in some of them we just go there at repeated intervals each year or each second year or third year, depending on the need of the need for monitoring of a specific dam, or according to the standard or practice that the dam owner has. We have also been working abroad in Canada and Norway and Finland and in US. If we look into the more details about the application in tailing storage facilities, we have eight worldwide, and of these we have 6 sites in Sweden. And what you see here is that they are the longest. We have almost 100 kilometers only in the tailing storage facilities sites here. And we have more permanent system on the TSF than we have on the hydropower side. So it's collecting a lot of data. And if we look at the sites here in Sweden, we have it in 8 sites. I have not picture on the 8th one. We will do the final installation here within the next month here. But the largest site we have is up at Kiruna. It's LKAB, and they have around 43 kilometers of cable all around there, both the tailing storage here and in the water clarification part here in the south and in different dams. And another dam for Boliden, where we started very early in 2010, that we have around 13 kilometers cable. So everything depends on the site of the dams. So in the some we have only in the water part, and in some we have them around both the sand deposit and the water. So most of this has been done on existing dams, but we have also been lucky to make installation during constructions, which is the best way. We have been asking ourselves, why do we have so many installations in Sweden? And I think the most important answer on this question is how the dam owners have shown the willingness to support new technology. They have been open, they have been interested in this technology. And I think they have also realized that the way of getting distributed information is very valuable. And you will be able to sometimes to have it all around the dam, and you will have detailed information, which is very important. And then it will be a good complement to the existing monitoring system. As I said, we can install cable both in new dams and in existing dams. We also have proved that we can measure several parameters, and I will give you a little bit background how this is possible. So we can use the cable for the same cable for different parameters. So that's really good. During the year, we have developed a data analysis tool, so we can do a lot online, and we can do a lot of remote operation if we need to see if the system is running properly and so on. We have also learned that the optical fibers within the cables, they are very durable, and they are running pretty well. If you make a careful installation, you will have a good chance that these cables will last for about 50 years. Is very reasonable, perhaps longer. The units that we have for monitoring, they're also reliable, but it is like a computer. After about 10 years or so, you will need a new one, which is better, have better performance, and that's therefore we say that the typical lifetime is about 10 years. Some are lasting longer for 12, 13, and some are a little bit shorter. A lot of this depends on where the monitoring unit can be installed. If you have large temperature variation or bad power supply, you will have a lower lifetime than if you have a good environment with the proper power power source. So that's important. And the monitoring here is based on the cable and the monitoring unit, and it's very easy to replace the monitoring unit. You just make a new calibration, and then you will start the measurements again. So you are able to go to do very good calibration, which is often a very tricky thing with other type of monitoring system and the sensors, to be sure that you are measuring the right thing, and therefore you have to calibrate. But this is very easy with this kind of system. So here we have the 4 applications that we have been using. We started in 1997 already to look into the application of temperature monitoring using fiber optics, distributed temperature sensing, DTS. Then in year 2000, we started with strain measurements, distributed strain sensing. Then in 2050, we started with dam breach verification system. And then in 2017, we started with acoustic sensing here. And everything here is made using the same cable. And you can see this installation here in the new dam. It's a hydropower dam, and you have the core of finer material here, and you have the filter. And here you have this just 6 millimeter thick cable, which is installed here. So when we are doing measurements for the dam breach verification, we look at the signal losses. And then we can verify where the cable is broken. And we can just, with this signal loss, we're just looking at if the cable is broken or not. That's not so intelligent. It's just saying yes or no. But we can also use this system with another monitoring system. For example, a temperature unit to see where the signal losses occurs and when they happen and so on. But this basic system is just saying yes or no. With the temperature here, we are using that for calculating the seepage flow rate, but also to, which is much easier to detect where you will have a seepage change, and that can be detected very early and at very small amount of leakage changes that occurs. And here you see two different systems that we have been using, and this is one for permanent installation. This is one for more field application. But it's also good. It can be running on a 12-volt DC system and working very well with good performance. The strain measurements, which is the strain along the cable, that's what we can measure. We can't measure the direction with this kind of system. We are just measuring if you have a movement and we know where it is. These are very sensitive. We are looking at strain changes about 1 microstrain, which is pretty small. So this is a very good system and will give much earlier response if you will have a movement than this DBV that is just saying if the cable is working properly or not. Then we have the most recent system. It's a development that has been done during the last 5 years, and we have been looking into this application. This is a system that can so to say listen to the sound waves. So you can either look at the environmental noise, or you can use active sources, and then you can apply typical standard seismic methods to analyze in the same way, but you are measuring this with the same cable as you have for the other here. So where to install this fiber? And this is a principal sketch of where we can put them in the new dam. We can put the cables in the upstream part, so we can see where the water enters. We can put them in the downstream part where we have the exit of the water that passes through the dam. And we can put them inside here in the filter or in the different ways. And by then we can, so to say, cover if the water passes through the core of the dam or if it goes under and coming up here. So that's different ways regarding seepage. And of course, if we wish to have acoustic measurement or strain measurements, we will put fiber on the crest here. And the typical installation is not to put all these dots here. We're just using one on the crest, one here, and one there. So a couple of lines is often sufficient. If you do for new dams, it can be like this. Or at this case, they were adding a tow berm, and we could install the fiber here. You can see the cable drum here, and you can follow it here, putting it a little bit upstream the drainage pipes here. You can also drill and put them in the vertical standpipes, which is a way in existing dam. And in some dams, we have just put cables downstream the dam. The dam is hardly seen here, but it's about 30 meters upstream here, and just putting a downstream trench here and put the cable there. So that's for hydropower. But if we go for a tailing storage facility, you have one example here that we studied. In this case, we were looking at the starter dam that you had here, and this is a case where the dam is fully built up and constructed. And if we then assume that we have some water here, and you have the beach here, and you have some kind of leakage going here, you can see the numbers here, and then you know that this water will pass here. And then we could look at, in this case, temperature, and see if we're measuring the temperature here, put a cable there, we could have this kind of seasonal variation. And if we put it here, we will have a little bit smaller. And if we put it here, it will have an even smaller, because then we are not measuring in the area where they have the seepage water passing. And here, if we put it there, we should have some kind of seasonal variation. So we can simulate and tell where to put the cables and what kind of potential use, and see if this theoretical value is okay and relevant for the monitoring. That will help the dam owner to decide if such a system will be useful or not. Here I'm just showing a photo on the crest of the dam showing where we have this DBV installed, and this is an example from Norway. And we have the cable here on the crest of the dam. So if this dam will breach, they will have an alarm that the cable is broken. They will not know where it happened, just that something happened there. And we have improved the system a little bit, but this has been running, and this system can be very reliable in order of in the way of monitoring. So they're running without any stop. So they are very robust and simple components that are used in other applications, which with very hard requirements. So this is good experience of running. This is an example where we have temperature, and you can see it's similar to this. Yeah, here you can see it start moving here. We are looking at the seasonal variation, and you can see here that we have assumed that we have a leak here in the dam through the core, and you can see that during winter you have cold water entering into this area here, and then you have warm water coming in the summer. And depending on where you put your cable, you will have different temperatures. And you can see here that the largest temperature here is in the red dot, and that is due to the heat conduction that we have from the surface. So this is coming down here. So that has to be been avoided. Here you have one figure that shows the temperature along 60 meter here, 50 meter of the dam, and here you have the temperature at different dates. And what you can see here in this area, you have small temperature variations. In this area here, you have larger, and you can also see that at this date in June, you have a very large, quick response. And this is a typical sign of a seepage area here. So we know that we have more seepage here. We can present the data either on a XY coordinate system, and you can see the temperature all along the cable in color marks. You can present the same kind of data at different times, showing this kind of diagram where you have the length of the dam here, and you have the time here, and you can see the different areas with different kind of temperature response. And this is the indication of different seepage flow rates. And here you have calculation of the flow rates. This can also be done for making alarms, and you can also here see how the deviation from the expected value differs. So here you can see areas where you have effects here, and this is due to snow melting, and this is due to rain, so it's not seepage related here. Some quick comments here regarding strain. I see that time is running quickly here. The strain movements we started here in research projects already here that was published in 2004, 2007. And we saw some areas in this dam where we have strain changes. So we are looking at the difference between each measurement. So we have a baseline here in September 4. However, we have learned that with the new Silixa system here that we have much better resolution. And this is example from a test dam that we built in Sweden a couple of years ago. And you can see the scale are the same here. And you can see that here we have 3 different data sets. And you can see that a lot of things have happened here in this area, while here you have very stable values. So much more accurate signal today than we had in 2007. So this is a really good system. Regarding acoustic, this is a new test that new method that we have been using in a couple of dams, both for research and for some applications. I'm not allowed to tell anything about the result in the real dams, but this is data where we see some different velocities, and the velocity depends on the material properties. So if you have different water content, or you have so to say increasing porosity, that will change the velocity of which is used for looking at the properties of the dams. So to conclude here, we have learned that these fibers that are installed in dam, they are useful. So if you're building a new dam, consider always to install fibers, because with temperature you can detect very tiny small seepage flow changes in space and time, and this can be done automated, and you can have alarm. So this is a very good thing. If you wish to have better control of the movements, you can use the DSS, where you can see where it happens if you have repeated measurements, but you can also see when if you have an online monitoring system. The DBV system can give you a very high frequent monitoring, but it's just either yes or no. So here you can use DTS or DSS. They are more sensitive and give you a more early warning. About the acoustic application with the ambient noise or active method, that can also be done. We are still working on a good system to have that monitor online, but so far we see this not as a standard tool, but hope it will be a standard tool also here in the future. So thanks for listening here. And now I leave the floor here to Andre to continue. Thank you for listening.
Thank you, Sam. That was very insightful. We do have a couple of questions. Xena, you can just put on the quick question answers to the attendants there, if you don't mind. Okay, then questions. Is there any drift in the sensing technology, Sam?
Any drift?
Any drift in the measurements? Yes. Is there any drift in the sensor?
No, that's the beauty of this system. The cable is passive, so it will not change anything. Everything is happening inside this monitoring unit. So I skip the details here, but I can, if you wish, I can tell you a little bit more of the monitoring technology. But it's easy to get lost in all these things. But perhaps
I know exactly what you mean, Sam. I think we can, if anybody wants, we do give them the opportunity to take this discussion further.
Yeah.
Okay, how does the system differentiate between groundwater and seepage?
The groundwater, as we have seen here in Sweden, we know that in some dams we have both groundwater flow coming in and we have water that passes through the dam. And groundwater is very stable regarding to the temperature variation. It's normal around the annual mean temperature. So if we plot the cross section, for example, we will see that in some area it's very constant temperature during the year, and in other areas we see that we have some kind of seasonal temperature variation. And then we know that the areas where we have seepage there coming from the dam or from the tailings storage facility, if you have water there, that is a sign that it's coming through the dam and not from the groundwater.
Okay, thank you. And the next one is here. Can the data be exported into third-party software, or is it a closed system?
We have learned, because it's so large amount of data that we are collecting. I mean, we are measuring each meter or each 25 centimeters. So when we are telling the dam owner, you need to take care of all these measuring points, they say that, okay, our system will not handle that. Keep it outside. We don't wish to interfere. But what we're doing is we are summarizing result and then exporting selected data points. So, for example, in one dam we have about 10,000 data points and are exporting about 200 to them. But that's the maximum that they can handle, and normally we are just exporting less than 100 data points into their system. But that's possible. And you do it with different export protocol. So that's possible.
Okay, thank you. And the next one is, you mentioned that already existing dams can be instrumented. Does that offer the same protection as an installation on a new build dam?
Yes, The only thing is that with a new dam, you can put the cable in the optimum location where you get the most and the best information. If you're putting it in the existing dam, you have limitation where you can drill or you can make a trench or whatever. So it's always best to install the cable in new dams. And we have also learned that if you make a careful installation, then you will have a very good system for a very long time, because the largest risk of for damaging the cable is during installation.
Okay. How does the calibration procedure work?
We have normally a loop in the beginning and in the end, and you may have it also on other points, and there you can put in an external sensor, so you can measure this very accurate. And you do that by adjusting the slope of the curve and the losses in the fiber and so on. So you're calibrating the entire line or entire loop, and you know that you are measuring correct in the beginning, and you know that you are measuring correct also in the end of the loop, and you can measure in both direction and test it in different ways. And then you know that, okay, it's good here, then it's pretty good also all along the cable. So assuming you have 10 kilometers and you're measuring each meter, then you have 10,000 points. And this is calibrated in just some minutes. So that's very good to calibrate all this so quick.
At what distances do you need to drill boreholes for accurate seepage detection?
To measure seepage, you should measure where you have the seepage, which means that you have to drill down to the seepage where you have the water table. So you are drilling down to the groundwater level and a little bit deeper, if you wish to drill. So that's depends on the situation.
I think the question is more at
Okay.
what distances next to each other.
Okay. Yeah. We have found that around 10 meters is a rule of thumb. You can that depends a little bit on the construction of the dam and so on. If you're afraid of very tiny small leakage paths, but you know that a typical seasonal variation will be seen 3-4 meters away on it. That's the speed of the thermal pulse based on the annual variation. So that there you will have some kind of small changes, and you can see it also a little bit longer, but everything depends on how sensitive you wish to have your monitoring system. I mean, you can if you have a very large canal, you have some spreading due to turbulence area and so on. Then it will be wider, but in some cases it's very concentrated, so it will just be heat conduction. So it depends on the actual situation, but 10 meter is a typical balanced assumption that you should have it.
Okay, and then we've got one. Can the data be pushed to a cloud?
Yeah. Everything is web based and cloud based, and and that's the only way to handle it. Oh, not the only way. Some dam owners wish to have this this web-based system within their firewalls, and that is also possible. But most of the clients have total web-based and cloud-based system that we are offering.
Okay, and then you mentioned that separate readout units are required to measure the different parameters using the same fiber.
Yep.
Example, strain, temperature, velocity. How much do such readout units interrogators cost?
That's the cheapest one is the temperature unit, and I think you have it in. We have to think in a good currency. If we start with dollar, I think you will have it around $70,000 or something. If you go for the DSS, I think that's around 120, and then then DAS is maybe a little bit 150. I don't have the numbers
That's okay,
exactly,
Sam.
but that's about that.
That's a discussion I can have with you guys. Just
Yeah.
reach out to me. My contact details is there.
Mm.
Then last one here, if a fiber can be used for up to 50 years, what do you need to do to ensure it maintains accuracy? Okay, so it doesn't drift. I think we've already answered that question. Then what characteristic of the fiber degrades that you can see that it that it needs replacing? So what breaks down in the actual fiber?
Yeah, what can happen is that if you will have so the additional settlements, residual settlements, and so on, and if they are very uneven and not perfect, then you will have, so to say, small changes, and that will stretch the fiber. And therefore it's very important to put the cable on good compaction. But if you will have such a situation, then you will have increasing signal losses, and these increasing signal losses will cause not so accurate measurements. They will be a lower quality, will have larger fluctuations and so on. So that you can follow, and we are checking. Our software is checking the signal losses before sending it into the database, like a quality check. Do we have the same signal losses? Fine, put it in there. If you have seen some local change with signal loss, then just wait, and we will have an alarm. Go there and check and see what's happening. So we can follow both where it happens and when it happens, and in some cases we can compensate for these additional signal losses with the temperature evaluation, and then we're coming back to high quality, but
Okay,
not as high as it was originally. I mean that the local changes may disturb the sensing.
Thank you, Sam. I think I don't know if it was mentioned, but I do think it's important as well that if the cable does break, the location of the break is detected. And like Sam said, you can measure from both sides. So if there is a break, you can still cover your asset by measuring from the other side, just using a different channel. And then obviously, fixing a fiber, it's a fiber splice at the end of the day. The actual core is nothing special about the core, but sometimes, the protection layers and things like that on the outside differs depending on application.
Yeah, but that requires that you have made a good design where to put the cable, that you have you can connect to both ends of the cable.
Yeah.
Because then you can measure, so to say, to the breach point from two directions. But if you just have one, so to say, single-ended cable and so on, you will not have that possibility.
Excellent. That was it. Thank you so much, Sam. That was very insightful from my side, and from Sam's side, I'm sure. Thank you very much.
Thank you. Pleasure to be here.